Okay, guys, today I'm gonna have to go ahead and go through my lesson through here. Got some other deals. Okay, so we're gonna be talking about isosceles triangles, equilateral triangles, and let me see. The way I will statement is we will see how different properties and proofs in both equilateral and isosceles triangles, and I will find the missing angles and property and apply properties of equilateral triangles and apply them to any proofs that we have. Okay, so let's go ahead and take a look at this stuff as a whole. Okay, so first off, it's kind of clear cut. Isosceles triangles, a triangle with at least one pair of congruent sides. Yeah, and so let me go ahead and change my font on that. 12 font should be a little bit too small, so 16. There we go. Okay, so legs. Well, basically, those are the congruent sides of a isosceles triangle, and they're opposite of the base angles. So this over here are base angles. I'll go ahead and get this right here. Okay, so this angle and this angle are what we call the base angles, and base angles are always opposite of the congruent sides. So that's why they call them base angles. So that's where we can go ahead and tell what's a base angle. So they're always opposite of the congruent sides. So let's see. And they're going to go ahead and say the congruent angles in these things. So congruent angles right here. So we can see that angle B and C are both congruent. So we can see them right here on this picture, right here and right here. Base angles. Okay, so BC. Okay, if you want to go ahead and take a look at this right here. If you take a look at sides B and C, this side right here, which is included in between, it's like the sandwich right here. So this is bread, and this right here is the meat of the sandwich. Right in between the two base angles is always going to be our base of the triangle. So that's where we got that. Let's go ahead and move this down. So it's always the included side of the side in between the base angles and what have you. Vertex angle is the angle that's not congruent to the other two angles. Well, we don't know if that's always true or not, because sometimes it is equilateral, so you'll get an angle that's equal to that. But talking about this one right here, in this particular case, this angle is opposite of the base. You can say that it's going the other way. So it's always opposite of the base. So let me write that. It's kind of funny how it doesn't want to go ahead and change that. Change that back to 16, so it's always opposite of the base. So let's see, theorems are always important. Okay. Change this right here. If two of the sides of the triangle are congruent, then the opposite angles opposite of them are also congruent. Alright. And so it's always true of those two. Let's see. Go ahead and grab those. Control D. And the converse of that states if two angles of the triangle are congruent, that means that the two sides are congruent. So this is the way you can look at it. Let's take a look at the first picture right over here in this diagram. Since we have side AB and side AC congruent, that means that the angles opposite them are also congruent. And if you take a look at the second diagram, which is over here, since we have BC those two angles are congruent, that means that AB and AC are both also congruent. Okay, so here we go. So find the missing angle. So since this side and this side are both congruent, that means that this one is also 68. So we're going to write 68 degrees over here on C. And then we have 68 plus 68 plus angle A is equal to 180. Well, 68 plus 68 is, let me see, 120 plus another 16. That's going to be 120 plus, okay, that's 136. Plus angle A is equal to 180. Subtract 136 from both sides. Well, that would be normally 50, but minus another 6 is going to be 44. No, wait a minute. Just making sure. Right now, since I'm a little bit tired, let's go ahead and check our work. Always got to check the work. So 68 plus 68. Okay, 180 minus 136. Yeah, 44. Got to check my work ever so often. All right. We won't do that one because it's just a recap. But then again, right here, we have this angle right here. So that means that this angle and this angle are congruent. So that's x plus x, since angle B and angle C are both congruent, plus 68 is equal to 180. Subtract 68 from both sides. So that's going to be 112. And that's these two add together. Divide both sides by 2. That gives us, let me see, 56 degrees. So B and C are both 56 degrees. Let me make sure. They always do a quick check. 180 minus 68 divided by 2. Yeah, 56. Find the missing value. So this angle and this angle are congruent. That means that this side and this side are congruent. So this is 3x plus 8 equal to 23. Solve for x. So 3x is going to be equal to, we subtract 8 from both sides, so that leaves us with 15. So x is equal to 5. Feel free to rewind to go ahead and watch these videos over and over again. Now in this one, it's a little bit more interesting. We're looking for x. X is the angle, the vertex angle way over here. We know that this angle and this angle are congruent. We know that this one and this one are congruent, so this one's also 65. We need to find out what this vertex is, because that'll give us these other two angles, because they're both congruent. So that's a vertical angle right there. So we're going to find out what the mystery angle is. Plus 65 plus 65 equal to 180. So we're going to go ahead and use that. So this is going to be 70. No, wait a minute. Sorry. Not thinking. So 60 plus 60 would be 120. So it's 130. 180. So mystery angle. So mystery angle is equal to 50 degrees. So that means that this angle is 50 degrees. This one's also 50. And this one's also 50. So since we have 50 for, let me write this. Let me go ahead and use a different color. Wish they made the picture a little bit larger. But oh well. So this angle is 50 degrees. This one's also 50. This is also 50. So if I were to do this, let me go ahead and clear up some space here. Sometimes you have to do a little bit to work this out. There we go. That looks a lot better. Okay. So, since we have these two angles, that's going to be 50 plus whatever x is, which is equal to 180. Well, let's see. 50 for 50 is 100. Oh, don't know why it does that. Every so often it just does something really crazy, kids. So it's 100 plus x equal to 180. Subtract 100 from both sides, so x is equal to 80. So that is our final answer on this. Can't answer any questions because I'm on a video. Okay, so here's a proof. And as you know, I don't usually follow everything that they have here, so let's go ahead and clear that stage for us. I'm going to be using the keyboard. I won't be using all these statements, but some of them I will be. Okay, so that works out a little bit there. So a couple of things that we notice. Okay, so first off, it says triangle PQR is an isosceles triangle. So this angle and this side are both congruent, because definition of isosceles triangles. It also says that QS is a perpendicular bisector of PR. So number one, these two angles are right. Number two, this side and this side must be congruent because of the perpendicular bisectors, because S becomes the midpoint. Also, QS, which is this side right here, is congruent to SQ, which means basically that it's the line that's equal to itself. So this side right here is also congruent. So we can use SSS congruency in this particular example. So I'm just going to write all that stuff down. So first off, we go ahead and go with our givens. So since I have a computer, I can use screen capture. I can use a capture tool. Oops, gotta move me out of the way. Let's use screen capture toolbar. Let's move you back down, Mr. Solis. Okay, so there we go, doing this. So I'm gonna capture this part because, come on, why should I work on even harder? So I'm gonna go ahead and save this to the clipboard. Get rid of that now. So I'm gonna put that. It's a little bit bigger than what it should be, but oh well. And we can make it smaller. Okay, so our reason here is that it's going to be a given. That's the given. These two parts are given to us. Okay. So next, we're going to have, let's see, PQ is congruent to QR. I'm going to use this. I'm actually going to write this out. Why is it doing that? PQ is congruent to QR. That's because definition. I should write that. Definition of, let me see, what's it called? Isosceles triangles. Okay, so it's definition of isosceles triangles. That's going to go right here. Next, we have QS is congruent to SR. QS is congruent to SR. All right, and that's definition of perpendicular bisectors. Finally, we have QS is congruent to SQ. That's reflexive property of equality. I'm almost out of time. And then finally, I'm going to run out of time, guys. Okay, I only got a couple of seconds left, but as you can see right here, reflexive property equality, so those two sides were congruent. So we proved this by SSS, and right here we have that triangle PQS is congruent to RQS, and that means that the angles are also congruent because of this definition. Congruent parts of congruent triangles are congruent. And we'll talk about more about that later.